Here we go. We have a question, house robber part 4. So there are several consecutive houses along a street, each of which has some money inside. There is also a robber who wants to steal money from the homes, but he refuses to steal from adjacent homes. The capacity of a robber is the maximum amount of money he can steal from one house of all the houses he robbed. So, capacity means the maximum amount that he can rob. Okay, so you are given an integer array nums which represent how much money is stashed in each house. More formally, ith house from the left has the ith element of dollars. So this is simple, and you are also given an integer k which represents the minimum number of houses the robber will steal. Okay, so we know that only two houses will be stealed. It is always possible to steal at least k houses. Yes, in this case k cannot be 3. Yes, at max k can be 2, right? So k can be 2 because we cannot rob adjacent house. And the main thing is we need to return the minimum capacity, right? What is the capacity? Capacity is the maximum amount, and we need to figure out the minimum capacity. Means we need to minimize the maximum amount of the robber between all the possible ways. So we need to rob two houses. So two houses can be 2, then 5, this is not adjacent. 2 and 9, this is also not adjacent. So we have uh, index 0 and 2, which means this and this. So between 2 and 5, the maximum amount is 5, which is the capacity. Capacity denotes the maximum amount between this robe, between the elements that we choose. So the capacity in this case is 5, and if we rob 2 and 9, capacity is 9. If we rob 3 and 9, capacity is 9, right? So we have given three capacities, and we need to figure out the minimum capacity. We need to find the minimum. Okay, so minimum between these three is 5. So this is our answer. We need to minimize the capacity. So this is the main thing. Then if I have given this example, so there are many ways to choose two houses, and the minimum between these two houses is index number 0 and index number 4. The maximum between this is 2, and between all the capacities, this is the minimum capacity. So the answer in this case is 2, right? So let's build the approach. So let's say I have given an array, and my k is 3, right? So k is 3. There can be many possible answer if I choose these three. If I choose these three, so there are many possible ways, right? But we need to figure out the minimum capacity. What is the capacity? Capacity is the maximum amount between all the elements that we have chosen so far, right? So we need to do this. So let's first find the capacity. So capacity is the maximum element, right? So what is the capacity? What can be the capacity? Capacity is as low as the lowest element, and as max as the maximum element, right? So we need to find the maximum element. So the capacity can be 40. So if I choose these three indexes, what is the capacity? Capacity is 14, right? Capacity is 14. And if I choose these if I choose these three, so capacity is 3 only, right? But if we have given 2, 2 and 2, so let's suppose I have given this array. So let me increase the size. Now it will work. So if I choose these two, but this is adjacent, so I have to erase this, and let me do it for this, and it will work. So if I choose this, what is the capacity? Capacity is the maximum element. What is the maximum element in this sequence? In this sequence, the maximum element is 2, right? So the lowest capacity can be 2, and the highest capacity can be the maximum element in this array, right? So we know the my lowest capacity can, what will be my lowest capacity, what will be my highest capacity. So before before talking about the optimized approach, first, what will be the brute force? Brute force will be 2 raised to power n, which is to take and not take approach. We are already familiar with this approach. And better approach will be better approach will be to like dp, to apply dp here, like house robber. In our house robber, what is the thing? Maximum between ith element plus I minus 2th element plus I minus 1, something like this. So we can easily apply dp in this case, and we need only k elements, so we will stop at max k. So it will be n cross k, n cross k time complexity, but this will not work because my n is very large and k is the half of this. So still it is not under, so this is not a good approach. So then we are trying something different. So we will talk in terms of capacity. My lowest capacity can be the minimum element, and my highest capacity can be the maximum element, right? So what is my minimum capacity and what is my maximum capacity? So my minimum capacity is 2, my maximum capacity is 14, and we have many different values in between these. And let me write k here. K is 3 only. Okay, so we have these many capacities. Inside of these, anything can be our minimum capacity, and capacity is the maximum element in this case, right? So we are trying to minimize the maximum element. Minimize, we are trying to minimize the maximum capacity. So our question becomes minimize the maximum capacity. So actually there are different capacities in this case. So this, then this, then this, right? So 2, 5 and 3, or 2, 5 and 10, and 2, 5 and 14, 2, 5 and 3, 2, 5 and 7, 2, 5 and 2, right? Then 2, 2, then 2, 2 and 10, 2, 2 and 10. So there are many different cases, and this is for k3, but it is not a compulsion that our k is 3. It is given our k is at least k. So this is for 3's, and our answer can be more than 3. Our sequence can be more than 3, this and this. So 2, 5, 3 and 14, and there are 4's, right? So I'm not making it a complex question. Let's simplify it. So we have k plus 1, we have k plus 2, we have k plus 3, and many more, right, till n, right? So it is given that we have at most, we have we have at least k, we have at least k houses, right? So if I given these k houses, I need to find a maximum between these. I need to find maximum between these k houses and these k houses, right? I have already told you that there are many ways to select k houses, and we need to select the maximum between these. We need to select maximum between k plus 1, we need to select maximum between k plus 2, we need to select maximum between k plus 3, and we need to select maximum between n houses. Or sorry, we need to skip adjacent houses. So n houses, but skip adjacent houses, right? Yes, but if I get this and find the maximum, isn't this maximum already covered in this? Isn't this maximum already covered in this? Isn't this maximum already covered in this? Right? So, k, so only k houses will make sense. K plus 1 houses or more than that will not make any sense. We are only going to select k houses. K houses will do the work for us. Or if the house is more than k, that's okay, but k is only k is sufficient to satisfy this condition, right? So we need to talk about capacity. So if I write this, if my capacity is greater than or equal to, so let's suppose 2, will this work? If my capacity is greater than or equal to 3, will this work? If my capacity is greater than or equal to 4, will this work? So capacity means maximum between these, maximum between the houses, maximum between k houses, right? So if my maximum between k houses is greater than or equal to 2, will this work? Is if my capacity is greater than or equal to 3, will this work? So I am talking about this. So something it will be false, and after that every value will be true. So that will make sense, because we need to find out the minimum capacity, and more capacity will do the work. We need to find out the minimum capacity the minimum between the maximum capacities, right? So uh, let's do the iteration. So will 2 make sense? It means if I select if I select 2, so my um, so my capacity is at max 2, my capacity cannot be more than 2. So can I select k houses? So my question is broken down into this statement. So my statement is, if my capacity is this mid is this is my capacity is, so let's say x. If my capacity is x, how many houses can I choose? How many houses can I choose? Okay, so if I can choose more than or equal to k houses, right? So will this work? So let's check. So let's first check for 2. So if my capacity is 2 only, my capacity cannot be more than 2. How many houses can I choose? So let's run this. Let's try to find out. Let me erase the unnecessary thing, and let's check for 2 only. So if my capacity is 2, and k is important, if my capacity is at max 2 only, the max 2, how many houses can I choose? Okay, so this capacity is, my capacity is 2 in this case. So can I choose this house? Yes, my house is initially 0, but now I can choose this house. I cannot choose because I have already choose this house. So then I have to go to this house. Is this capacity, is this amount less than or equal to 2? No, I cannot choose this house. Can I choose this house? Yes, I can choose 2 houses. Can I choose this house? No, because this is adjacent. I have to directly jump into the next to next house. Can I choose this house? Can I choose this house? Can I choose this and this? Yes, I can choose this house. So I can choose 3 houses. Yes, if my capacity is 2 only, I can choose 2 houses. I can choose 2 houses. But so 2 will work fine. 2 will work, right? So how 2 will work? Houses I can choose is 3, and I require to choose 3 houses at at least 3 houses. So this statement will work. Let's try to find for this value. If my capacity is at max 3, how many houses can I choose? I can choose this, go into this, I can choose this, then I can choose this, I can choose this. So I can choose 4 houses. My houses is 4, which is greater than or equal to this value, which is the required number of houses. So I can choose at least k houses, right? Yes, I can choose 3 houses. If my capacity is 4, how many houses can I choose? I can choose these houses. I can still choose 4 houses, so 4 will also work. How many? If my capacity is 5, how many houses can I choose? If my capacity is 5, how many houses can I choose? I can choose this, I can choose this, I can choose this house, I can choose this house, I can choose 5 houses. So this will work. Yes, so anything more than this minimum value will work, right? This for this test case, this will work, right? So talk about for different let's talk for different test case. So let me erase this and let me write a different test case. So I have taken this example, and what is my lower bound? My lower bound is 2. What is my higher bound? My higher bound is the maximum element, which is 12, and I have a range. If my capacity is 2 only, how many houses can I choose? So I can choose this house, I can choose this house. So houses I can choose is 2 only, but we need to choose 3 houses, so 2 will not work. If my capacity is 3, how many houses can I choose? I can still choose 2 houses, which is not enough to satisfy 3 houses. If my capacity is 4, how many houses can I choose? I can still choose 2 houses, so 4 will not work. If my capacity is 5, how many houses can I choose? I can choose 2 houses, so 5 will not work. If my capacity is 6, how many houses can I choose? Only 2, but I need to choose 3 houses at least. At least I need to choose 3 houses, so 6 will not work. If my capacity is 7, how many houses can I choose? 2 only, which is not enough to satisfy 3 houses. If my capacity is 8, how many houses can I choose? Still 2, which is not enough to satisfy the condition. If my capacity is 9, how many houses can I choose? I can choose 2 houses, which is not enough. If my capacity is 10, how many houses can I choose? I can choose 3 houses, so 10 will do the work, right? So if my capacity is 10, I can choose 3 houses. And if my capacity is 11, how many houses can I choose? I can choose 3 houses, which is enough to satisfy at least k, at least 3. So 11 will do the work. If my capacity is 12, how many houses can I choose? I can choose 3 houses, which is enough to do the work, right? So till a given range, we have crows. After that, we have ticks. So can we apply binary search? Yes. So first of all, we have we know our L, we know our R, we will find our mid. Our mid is this. Then if my capacity is 7, how many houses can I choose? Right? I am not talking about K. Let's skip K for a second. If my capacity is 7 only, how many houses can I choose? If I choose this house, I have to jump to next house. Can I choose this house? It means my element is less than or equal to mid. No, this will not satisfy this. Then I will go to this. Will this satisfy? No. Will this satisfy? Yes. Then I will jump to next element, because I need to also follow the first rule, which is to rob to do not rob the adjacent houses, right? So if my capacity is 7 only, I can rob two houses. If my house is less than k, it means I need to go to right hand side. I need to increase my capacity. My capacity will be increased. I will just change my L to mid plus 1, right? So let's change my L to mid plus 1. So 14, my L is here. And what will be our mid? Our mid is 10. If my capacity is 10, how many houses can I rob? I can rob this house. Then I have to jump to next house. Can I rob this? No. Can I rob this? Yes. Then I will jump to next. Can I rob this? Yes. I can rob 3 houses. If my house is greater than or equal to k, it means I can rob at least k houses. So mid is correct, or the answer may be on the left hand side, because we want to find out the minimum capacity. So my answer is the mid, and I will go to right hand side. I will try to find the minimum capacity. So let's code this. So first thing first, I need to find L and R. So let's take L as 1 and R as, so arrays dot stream nums dot max dot get as int. I think this is a correct way to find the maximum element, if I am not wrong. Let's run this, and yes, we can find mid like this. Then what things we need more? We need n also. Then let's find this and this. Find a mid. If my capacity is at max mid only, how many houses can I rob? How many houses I will rob? So we need to find out the houses. And if element is less than or equal to mid, so I can rob this house, because at max I can rob mid rupees. I can rob mid rupees from a house. So I can rob this. So my houses to be robbed is incremented. Next, I will be incremented once, and this update operation will do the updation one more time. So it will skip a house. So this satisfy the first rule, which is to do not rob the adjacent houses. If I can rob k or more houses, so my mid is correct, or my answer is on the left hand side. Else we need to increase the capacity, right? So that's enough, and let's run this. Yes, let's submit this. Yes, working fine. Let's discuss about the time and space complexity. So we have while loop. This while loop is for binary search, and we have upper bound as the maximum element, so it is log of maximum. Inside of this we have for loop. So for loop will iterate for n times, so it will be n multiply log of maximum, and the space complexity is constant in this case. And that's all. Code is provided in the description box. Thank you all for watching.